Alternating series test. This is easily recognizable series because of the presence of -1 to the n or -1 to the n plus 1. I want you to take note of the a sub n, okay? That a sub n must be positive, meaning the terms of the series must be positive. Of course, disregarding the -1 and the -1 here, okay? The limit of a sub n as n goes to infinity must be 0. These are the two conditions that must be satisfied. And the second condition is that it is decreasing. The terms are decreasing. A sub n plus 1 must be less than or equal to a sub n. Okay, let's look at this series now. -1 to the n over n times ln of n, and starting from 2 to infinity. Okay, noting that if n is equal to 1, then ln of 1 will be 0, and that will not be defined. So n starts at 2. Let's look at the first condition. Is the limit of the n term equal to 0? Is the limit of 1 over n ln of n as n approaches infinity 0? The answer is yes. Now let's look at the second condition. Is 2 ln of 2 less than or equal to 1 over n ln of 1? Yes, of course. And this is less than 1 over 3 ln of 3. And so the second condition is satisfied. And because these two conditions are satisfied, then the series converges. Now, with this -1 present in the series, there is another thing that we need to consider. Does the series converge conditionally or absolutely? The series converges conditionally if the series represented by the absolute value of a sub n diverges. So it conditionally converges if the series represented by the absolute value of a sub n diverges. It converges absolutely if the series represented by the absolute value also converges. So let's look at the series. Does it converge conditionally or absolutely? We will now consider by the integral test the integral 2 to infinity of dx over x ln of x. Remember, we do not include the -1 anymore. So using u substitution, I will let u be equal to ln of x, and the derivative of that with respect to x is 1 over x. Okay? So this integral now becomes ln of x is u, and the dx over x is our du. So this is actually ln of u. So putting back our u, the integral is equal to ln of x, and we will now evaluate this from 2 to infinity. Well, ln of infinity is infinity minus ln of 2. Well, what is the significance of this against infinity? So we say the integral diverges, and so this particular series converges conditionally.